Hello. In the last video, we discussed about problem-based learning, its concepts, and an overview of the complete process. In this video, which is again pertaining to problem-based learning, we are going to discuss in detail the steps for implementation. The step 1, as in any other collaborative learning process, it would be forming teams. And the same attributes, the same points that you need to keep in mind for any other collaborative process, you need to keep in mind for PBL too. How do you structure the group to let each student's strengths shine? Because collaboration, the best outcome from collaboration can come only if the team cohesion and the team members work on their own capabilities and work on their weaknesses too. So a best way would be you can take a pre-test to assess individual capabilities of each student in the class, or then you can then randomize the distribution of the students to learn to make teams, or you can make homogeneous teams too. In case of problem-based learning, it is possible to make homogeneous teams too, depending on if there is a group of students and they want to work together. All of them have got very good problem solving capabilities. You can put them in the same group. And those who have lesser capabilities in terms of problem solving, you can keep them in the other group. But the catch here is that you might have to give different problems as starting points to different groups in case you are making homogeneous groups. And in case you are randomizing or making heterogeneous groups, the same problem can serve as the starting point for all the groups. And this is again a differentiating factor from any other collaborative process, that you enjoy a more freedom in terms of formation of groups and teams in case of problem-based learning. What size of team would be ideal? It has been found that in problem-based learning, the best team size could be 3 or 4. But it also depends upon the total class strength, how many groups you can handle. So if it's a big class, you may like to have them have less number of groups and have more number of team members in the group. But if it is a small class, you can have smaller groups also. And in problem-based learning, I would strongly recommend that if you are doing problem-based learning for the first time, you should have either an assistant or a co-faculty member to support the process, because PBL is a very cognitively overloading process both for the students and for the facilitator. So if you are doing it for the first time, you must have some support or assistance available in the class. Later on, you may become expert and you would have anticipated all the steps in the process of PBL and you can handle it alone. Also, after some sessions on PBL, you will find that there are some students in the class who can also serve as your assistants. So these are all things which I am sharing based on the experience that I have had personally on PBL. So my advice is, if you are doing it for the first time, have some kind of assistance available in the class. Also think of what is the total duration of the activity. If the activity is very long and it is going to spill over to the next class, you must have some connecting links in terms of material or in terms of some discussion forums, so that the learning doesn't die between two classes or when the next class comes and it is falling in the ambit of the total PBL process. The step 2 is deciding the opening activity. I think I have dwelled upon the opening activity or framing an ill-structured problem a lot in my previous video. And since this is the single most important aspect of a PBL process, you must devote a lot of time on deciding and designing this opening or guiding activity. It has already been discussed that the problem cannot be, and when I say cannot be, it is in bold and capital, It cannot be an end of the chapter problem. So it cannot be a closed-ended problem, because a closed-ended problem may not require collaboration to take place amongst the students. If the student is able to solve that closed-ended problem or the problem at hand individually, there is no collaboration or teamwork going to happen in the PBL. And PBL is essentially a collaborative process. So the guiding activity or the problem at hand should be fairly open-ended. And to re-emphasize and to reiterate what is the difference between open-ended and closed-ended problem, I'll give you an example. Supposing the task at hand, and this example I am not taking from any engineering course or situation, I am taking it from a fairly life skill kind of a situation. So supposing there is a group of students who need to cross a river. And if you specify the problem to the students in this way, in the following way, that there is a river whose banks are 200 meters apart, and there is a boat available for you to cross the river. How much time will you take, or how much and what process will you adopt to cross the river? The solution is simple, and pretty much only one solution is existing for this particular problem, that all the students have to take the boat and they must know rowing before taking the boat and rowing it to go to the other side of the bank of the river. Change this problem to this in the following way. There is a river and you as a team have to cross the river. You have to complete this activity in next half an hour. This becomes an open-ended problem because the students not only have to first gauge what is the width of the river, they have to also find out what process they can adopt to cross the river. Some of the students may simply swim across. The others may think of collecting some wood, plunging onto it, and take some time to cross the river. The others may even go further, collect the pieces of wood which are available, try to make a floating boat or a floating paddle, and then all of them can go together on that particular boat to cross the river. The point that I am making here is that there is a lot for the students to play around. A closed-ended problem, which in this case for the first example, you do not need any kind of collaboration. There is only one solution existing, and that particular kind of problem is a bad example for a PBL process. A PBL process should definitely have as a driving question or as a driving activity a fairly open-ended problem as illustrated in the example that I just gave. Also, it should match with the time frame that you have in mind for completion of the activity. So you cannot give the students something which is fairly open-ended or open-ended, and the students can take infinite time to solve the problem. After all, the class time is limited, the course learning objectives are well defined, and you have only that limited time to complete those course learning objectives. So it is a debate of how much open-endedness you want to assign to a particular problem which is going to serve as the driving question. So in problem-based learning jargon and in engineering education jargon, a term has coined up which is known as quasi-open-ended, which means it lies between open-ended, completely open-ended, and closed-ended. So it has some parameters to play with, but it is not completely closed-ended too. So it becomes a quasi-open-ended problem, and they serve as good examples and good points as driving questions for a PBL process to be adopted in an engineering course. Designing of the problems, if you are thinking that you are going to design a complete course or you are going to teach a complete course based on PBL, or you are going to teach only a portion of the course using PBL and rest of it using traditional lecturing, that's perfectly fine. So what you should do is, you should define or you should come up with 1 or 2 problem sets per topic. That is, if you have 10 units supposing in your course, maybe you can frame, if you're thinking of delivering the whole course using PBL, maybe you can come up with 2 fairly open-ended problems per topic. That is 20 problems in the whole course if you have 10 units. The second point is, they are not truly open-ended, as I just said, because a truly open-ended problem would require a lot of time for the students to actually solve it. So they should be made broad enough, or in other sense, quasi-open-ended, so that they cover all the issues and the learning space which I showed, the technical nodes or the learning objectives. There should be at least 5 to 6 per unit learning objectives which should be completed using that quasi-open-ended problem. The problem sessions, mind you, if you're thinking of having even 2 problems per topic, both the problem sessions should be interlaced with practice or assignment sessions. Because remember, problem-based learning is only a superset of problem solving. So unless the students solve or unless the students practice the technique of solving problems, they are very less likely to attempt problem-based learning. So always interlace your sessions of open-ended problems with assignment sessions or to-do or practice or analysis sessions. So let them do that also while they are actually working on the problem-based learning assignments. So this is what is the layout, this is what should be essentially the layout of problem-based learning sessions. How should you introduce the activity? And remember, this has been listed as an exclusive step, because remember, half begun is well done. So when you introduce the activity, you have to explain the activity, clarify the objectives. For what objectives this particular activity or this particular problem has been thrown to the students. Outline the procedures. When I say outline the procedures, it's not about giving them the process. Let them figure out the process. But you need to give an outline of the process or the procedures, because remember, the time is limited. The students cannot work infinitely on a particular problem at hand because it's an open-ended one. Give examples if needed, as I just gave. The ground rules. In collaboration, in any collaborative activity, it is very, very important to define the ground rules for group interaction. Because it has been found, the literature and surveys and the research also shows that if you do not keep a quick and right check on the students, the collaborating students have very high probability of wandering away from the learning objectives for which the activity was defined. So remind them right at the beginning of the ground rules for group interaction, set time limits. If there is an outline of the procedure which has been shown to them, you can tell them, very well show them, that these are the time limits for each particular process or step. Define interim objectives too, and that you can do in association with the students. Provide the prompt, task or problem only after this. So once you have explained the activity, the broad objectives, after giving examples and after defining the ground rules, telling them that this is the complete time frame that you have to achieve these objectives, you have to provide the prompt, the task or the problem, and then ask them, motivate them to ask questions on the question itself. So whatever is the problem, it's very important that the students understand it. If they do not understand the problem itself, they are very much more likely to fail in achieving the learning objectives. So ask them to feel the questions or to ask the questions on the problem itself. They could be asking stupid questions because remember, you have not delivered any content or prior knowledge to them to solve that problem. So let them ask questions. Let them ask questions on teamwork. Let them ask questions on the problem itself. Let them ask questions, or if they are not doing, motivate them to ask the questions how this is related to a real life situation. And then you dwell yourself onto the resources. Now that is a smart teacher. If you can actually think of the resources that the students are going to need during solving that problem, you are a smart teacher. So the example of crossing the river, which I gave earlier, a smart teacher would actually think of what are the all possible ways that the students can adapt or adopt to cross that particular river and keep those resources handy. So for example, some students may come up and say that, sir or ma'am, we want to cross the river by swimming. Do you have the required safety gear in place so that they can swim across the river and go there? If you do not have, the students and you yourself are going to waste time to arrange for those resources. If some students might think of making a boat, do you have the wood logs ready, the logs of wood ready, the nails, the hammer, the rope? So all kinds of resources which are required to make a boat, you may not give them right at the outset, but let them ask for it. And if they are asking for it, you should be ready with those resources. So think of this example situated and contextualized in your own course. If you are giving them a problem and they would require a particular book, resource, methodology, equation, derivations that they may require to solve that particular problem at hand, sometimes practicals too. Are you keeping them ready? Do you have them ready? Or you would afford, or you can afford to waste or devote some time to look for those resources? I'm sure you will not have that amount of time. So think through the process the students would adopt to perform the task. Think through the resources they might require and keep them handy. And if you have thought of 4 kinds of resources and they require the 5th one, you are failing in your objective. But that is also a learning for you as a teacher. So that is why I say, as much as the students learn through a PBL process, the teacher also learns through the PBL process. And that's the beauty of the problem-based learning. Because each time you carry out a process of PBL with your students, the teacher also becomes much more richer in experience and knowledge as much as the students, or maybe more than that. When the need arises, you should be in a position to provide those resources. So the resource management is something that you also as a teacher learn as much as your students. Very important, guiding, facilitating through the activity. Some of the points mentioned here are same as you would do in any other collaborative process. Keep a watch on the cohesion of the team members. Remember, this is not an individual activity, this is a collaborative activity. Keep them motivated. The researchers and the practitioners have actually shown, and many a times reproduced in their research papers, that keeping the motivation high when the collaboration is going on is sometimes and more often than not becomes very, very challenging. Show interest in the problem that they are doing and the process that they are adopting, but intervene only when required. As teachers, we are very, very tempted and sometimes become over tempted to intervene even when it is not required, because we have the habit of showing that we are the know-it-all. Let the cognition take its own way. Let the cognition among the students build, and you need not to intervene unless it is required. And they would actually figure out the process and the path to find out the solution of that particular problem. And remember, this particular generation is alpha generation. So they know it all more than what the teacher would know. But your experience is something that they do not have. So let the conceptualization take place amongst the students. When the application part comes of it, then you show them, then you intervene. So that is the right point that you should intervene, and don't hesitate in giving them sometimes negative triggers too. Because failures are also very important for the students to learn. And when they would not be able to find a solution to a problem, and remember, this is an ill-structured problem, they would learn more than finding out a solution right away. So give them negative triggers, move them away sometimes from the ideal learning curve, and you will find that the learning is taking place more than if they would be following an ideal learning curve. And that is what is the problem with our traditional teaching method, that it always follows an ideal learning curve because the teacher knows it all. Watch if they are working towards the learning objectives. Are they not wandering away too much from the learning objective for which this problem was designed? Are they working for the solution, or they are doing something else? Time is precious. Keep a watch. Formulate fair share policies. More often than not, in all types of collaborative activities, you will find that in a team of 4, 2 are working, or maybe at sometimes only 1 is working. The rest 3 are just enjoying. And that's where your duty comes in. You have to define fair share policies and see that each student is at least working on the part or which has been assigned to him, or in which he is good at. At least he is working on his strengths. Don't sit idle. While the process is on in the class, be alert and wander around in the class so as to reach every team. I have seen some of the very fresh teachers who start doing PBL process, they feel relaxed that I have given the onus of the learning and finding a solution to the problem to the students. I have to just grade them at the end, and that's wrong. Because if the precious time is lost and some of your students are not able to work towards the solution, the learning is not going to take place. And the objective of your designing PBL process was not because you were not satisfied with traditional teaching. That's still the best way of teaching. But why did you do PBL? Because you wanted the students to take their own learning onus, and also you wanted the students to develop better problem solving skills and life skills too. So it's as much important for you to be intervening and to be seeing all these points when the students are going through the PBL process as much as it is important for the students. So don't sit idle. And I have seen myself that many of the teachers do this. And at the end of the day or the activity, they say, no, it didn't make any difference to the students. They are all the same. They are not doing their bit. But did you do your bit through the PBL process? That's what is the question. So putting everything together, here is a flow chart. Here is a complete process. And I would like to take some time in going through each of these process steps and putting everything together. And this one is a student's perspective. The earlier steps, the 4-step process which I have shown, it was a teacher's perspective. Now this one is a student's perspective. How do students perceive PBL process and how should they do it? The students receive a problem. They are then expected to explore the problem statement and break it. Break it into what? Break it into smaller, well-defined problems. So the third step is frame questions and then prioritize learning objectives. What is it that I am going to learn when I work on this particular subset of the well-defined problem? And remember, the well-defined problems is actually made up or derived from the ill-structured problem or the life situation which you as teacher has posed to them. So when they are actually defining the questions and prioritizing the learning objectives, here is a time that a document has to be generated. You will see in this whole flowchart that I have given circles in which either doc or D is written. So these are the points which are the documentary evidences of how the students are actually following the process. So when they would have framed questions, divided the ill-structured or the open-ended problem into smaller set of problems or questions, ask them to generate a document and get it verified from you. Because if they are able to generate the right set of questions and prioritize the right set of learning objectives, the chances are that they are going to finish the complete problem in the given time frame. So the next step obviously is authenticating by the facilitator. If required at this point of time, there is a looping back. You can ask them if you are not satisfied with the questions, with the subset of problems. You can discuss with them and ask them to reframe it. Then, very important aspect is exploration of approach, criterion, objectives, resources. In terms of what is the acceptable evidence that this question or this problem at hand has been solved correctly. Can they generate that particular evidence? Which means that if they know what is the evidence and if they develop an understanding of the question and the evidence, they will be able to definitely find out a process and criteria to work upon those objectives to find a solution to the problem. Sometimes the students would take a longer approach, and that's perfectly fine. But does it fit within the time frame? That is what you have to see. So the next step obviously is to optimize their approach, objectives and resources. Look for if they are wanting a lot of resources which may not be required to generate a solution to the problem, or are they requiring very less number of sources? Are they taking a very long approach to solve the problem? Are they taking a very short approach? It's okay to work with both of them, but you have to keep intervening only to optimize what they are doing and how they are achieving. The intervention is again very, very subjective to the groups. Some groups may require lesser amount of intervention, some groups may require more. Apply successive approximations. Work distribution I have already said. Collaborative learning is very much dependent upon work distribution and how the teams are working together. Time management. In fact, the next row is actually totally on the teamwork. So when the technical aspects are taken care in the top row, the next row is actually on the work distribution and team cohesion. Then at each point, they are generating documents to be cross-checked by you, and they are also your assessment and evaluation points. So in fact, you can actually assign assessment criteria to each of the documents which has been generated in the process. And then if you have many more problems to be tackled with the students, you have more problems that can be framed, given to the students, practice, prepare for presentation, and then, as I have said earlier, you must assign some time and keep some time aside for the students, for the groups to interact amongst each other. When the presentations are happening, the learnings are being shared, because in this particular case, learnings may vary very widely amongst the groups. So let the learnings also be shared amongst the groups, and then obviously evaluation cannot be ignored. So the grades have to be declared, and more often than not, in PBL process, if you have done everything correct, the students are definitely more often than not satisfied with their grades. As I said earlier, PBL is not only a process which should be termed or which should be seen only in the perspective of content or only in the perspective of pedagogy or only in the perspective of assessment. So when the students are centered, this particular learner's triangle has to be kept in mind, and the strategy for pedagogy, for content and assessment has to be co-designed and co-thought. And in case of PBL, it is more important than any other pedagogical instruction. One very important aspect, since it's a collaborative activity, I have given some photographs of what kind of a class, a PBL class infrastructure would be best supporting a PBL process. You will see here that these chairs and the chairs have been arranged so as to facilitate group work. It's not a traditional classroom. You will also find in the next slide, this one, that there are some lab setup also has been created. So in PBL processes, many a times the students co-work in the practical and the theory. So they would like to verify the results, what they have generated through their problem solving. They would also like to verify practically. So this is the kind of infrastructure which supports PBL. Some of the challenges, the most important one is that students and teachers have the psyche that the learning is governed by grades. So the last but fourth point, be governed by external evaluation always, is something that we as teachers and the students as students have to get over. Because the process should be governing the learning, and the learning should be governed by the process, not the grades. So some of the challenges we have already discussed earlier, but most of the time it is our upbringing as teachers and it is the upbringing of the students which creates more of challenge than anything else. Some of the findings, I have discussed these findings earlier too during the discourse of last 30 minutes, but a couple of them I want to highlight here. That in PBL, and that is coming from my experience and from literature too, absenteeism in case of PBL classes is very minimal, and many research papers and findings have shown it. Indiscipline problems, they reduce quite a lot when PBL processes are on, and you can relate to it because the students are motivated. They are driving their own learning. They are defining their learning objectives. They are defining the processes. So the indiscipline and absenteeism problem is minimal in PBL classes. And the literature and the research has shown that the students tend to spend more time in the class. They don't want to leave the class. They want the collaboration to be taking place more and more. And they find time to generate more solutions to the same problem. And isn't it fantastic? So these are some of the advantages, findings from the experiments in PBL. But a word of caution, word of advice, don't be over optimistic when you are practicing PBL for the first time. Because there have been findings wherein PBL has not done as much good to the students as it should have. Some more findings. The last one is important. Even if the group is not able to reach at the correct solution, the way it uses metacognition, remember we talked about metacognition? The way it uses varied approach to reach the same causes learning to take place. So let them take as many or as much processes and steps that they want to take to reach at the final solution, optimize it, and the learning that is going to take place through the metacognition is fantastic. Obviously, it improves communication and presentation skills of the students also. In traditional, you can't say so. And these all findings have come from various research papers and from my own experience, and you can find them in the published work. So we actually in this video, we deliberated upon the whole process. I also presented a flow chart and the step-by-step activity that you need to take when you are actually going to take a class on PBL or maybe a course on PBL. I also presented the teacher's perspective and the student's perspective. And remember, PBL is a complex process. So take smaller chunks of it when you are actually deciding to do it for the first time. But the experience is only going to make you better. Thank you.